Good morning dear students, welcome back. So this is the continuation of model question paper discussion for module number 4. Already I have discussed about 7 questions, 7A, B, C. Now comes the question number 8, 8A. Explain the phenomena of superconductivity and discuss qualitatively the BCS theory of superconductivity for negligible resistance of metal at temperature close to absolute zero. Question appears to be very lengthy, but overall summary is this. You have to explain what is superconductivity and give a brief account of BCS theory. Superconductivity, as you all know, is nothing but zero resistance state of the substance. See here, the phenomena in which electrical resistance of a material suddenly disappears or becomes zero below certain temperature is known as superconductivity, and material exhibiting this property is known as superconductor. Temperature at which this happens is known as critical temperature. Now we have to explain this with the help of BCS theory. BCS theory was proposed by 3 scientists, Burdeen, Cooper and Schiffer. B for Burdeen, C for Cooper and S for Schiffer. This theory is totally based upon the formation of Cooper pairs. First you explain what is Cooper pair. See here, BCS theory is mainly based on the concept of Cooper pairs. Cooper pair is a pair of 2 electrons having opposite spin and momenta. Electrons are paired via lattice vibration. Energy is exchanged between lattice and the electron through a quantized particle called phonon. They are formed in at a very low temperature. I already explained this in my regular video. Let us say this is a lattice plane where atoms are sitting here and there. One electron is going like this, another electron is coming from this side. So when 2 electrons are moving in the opposite direction, they form a pair. For the formation of pair, lattice should vibrate. If lattice is not vibrating, then electrons cannot form pair. It is a sort of virtual attraction. And these 2 electrons are now staying together. So therefore I can say there is a sort of bonding between them, and that bond is very thin. Energy required to break the bond is very small. Therefore the Cooper pairs exist only at very low temperature. If you increase the temperature, that temperature itself is enough to break the bond and electrons start moving away. So Cooper pairs are formed only at very low temperature, and that too with the help of lattice vibration. Please watch my video on Cooper pair formation. Okay, well, Cooper pairs are formed, and these Cooper pairs exist only at very low temperature. That is why superconductivity is a very low temperature phenomena. Okay, now I explained what is Cooper pair and how it is formed. Let us proceed further. Cooper pairs will be having good correlation and stay together over a large distance. And between 2 Cooper pairs, this pair and another pair, not only 2 pairs, between Cooper pairs, any number of Cooper pairs, there will be a sort of mutual understanding. This is what is called as correlation, understanding or correlation or cooperation. And all of them will move in the same direction within a small distance of 10 power minus 6. Actually I have called it as a large distance. Within the material, 10 power minus 6 is a very large value only, but for us, okay, in day-to-day life, my 10 power minus 6 is a very small distance. But within the material, we talk in terms of nanometer, we talk in terms of angstrom. Therefore 10 power minus 6 is large only. So within 10 power minus 6 meter, you find huge number of Cooper pairs. They all will behave like a single molecule, and hence we call it as a macromolecule. And all the Cooper pairs will be explained with the help of one single wave function. One wave function is enough to explain all the Cooper pairs. See, in quantum mechanical world, particles are not treated as particles, they are treated as waves. I already explained this in the modern physics concept. Okay, each wave is explaining the particle, or each particle is associated with a wave. If all the particles have got only one type of wave, then all the particles are alike only. So that is what is going to happen in case of Cooper pairs. So Cooper pairs are behaving like a single molecule, and they start moving in the same direction. Suppose if there is any collision, the particle, the Cooper pair will not break up and will not deviate from the direction. They continue to move in the same direction. Therefore, even if there is an obstruction, even if there is an opposition, Cooper pair will not take it as an opposition. So therefore there is no resistance at all. After all, what is resistance? It is nothing but opposition. So and how resistance arises? It arises because of the collision. But when Cooper pair collides, they will not take the collision as an obstruction. They will not take it as a disadvantage. they will take it as an advantage. They continue to move in the same direction, all of them, like birds flying in the sky. They all continue to flow in the same direction. So the flow may change, but the drifting in the same direction. So like this they are going, next they go like this, but not in random direction. That means always there will be conductivity, and that means there is no resistivity or zero resistance. So that is what I have explained here. I just read it for you. The entire set of electron pairs is now moving in a particular direction and constitute electric current. To resist such a current, one has to alter the correlated motion of all the pairs. Alter ಮಾಡಬೇಕು. ಹೆಂಗೆ? By means of collision. Since it requires a relatively large amount of energy, current persists for a long time. So ಅವನು ಬ್ರೇಕ್ ಮಾಡಕ್ ಆಗೋದಿಲ್ಲ. Therefore current will exist always. This is how zero resistance state is attained in the in the superconductor. So this is a schematic sketch of Cooper pair. I have two electrons connected by means of a lattice vibration. So between them energy is exchanged in the form of a quantized particle called phonon. So this is Cooper pair, and the energy gap between the energy of this bonding is Eg. It is about 3.53 K into Tc. Okay, see, look at the very small value of the energy gap. That's why temperature is very small. So superconductivity is a low temperature phenomena. Well, now I come to the next question. Give the qualitative explanation of RF SQUID with the help of a neat sketch. RF SQUID means radio frequency SQUID. You know what is SQUID? SQUID is a superconducting quantum interference device. It is mainly used to sense the magnetic field, used to measure the magnetic field of smaller value, about 10 power minus 10, minus 20, minus 15 Tesla, like that. Such a small magnetic field can be detected with the help of SQUID. In SQUID there are two types, DC SQUID and RF SQUID. AC SQUID also it is called as. How this RF SQUID works? Okay, here is the definition. RF stands for radio frequency. RF SQUID is a one junction SQUID loop that can be used as a magnetic field detector. Actually it is less sensitive compared to DC SQUID, whatever it may be. DC SQUID is also equally important. Okay, so here I am explaining RF SQUID, but the notes what I have shared already with you in my previous videos, there is a detailed explanation of DC SQUID also. Okay, please refer to my notes for the examination. Okay, construction and working. Dear students, look at this. This particular square is a Josephson junction, and there is only one junction, therefore it is called single junction. And in this junction, in this portion current is flowing, so the dotted line represents current, and the cross mark, no, it represents magnetic field. So SQUID always consists of a Josephson junction, either one junction or two junction. If there are two junctions, it is a DC SQUID. If there is one junction, it is AC SQUID. Okay, and it is applied with magnetic field, perpendicular magnetic field. So into mark represents field applied to the SQUID. By the side of that, I have a LC circuit. L means inductor, C means capacitor, and this LC circuit is connected to AC power supply. RF AC source means radio frequency AC source. Radio frequency means less frequency. Okay, and I also have voltmeter connected parallel to inductor and capacitor, that you can make out easily. Actually what happens here, I will tell you. Already I have applied magnetic field to the SQUID, that is let us say phi is the magnetic flux. Okay, and then when I switch on the LC circuit, then current will flow in the circuit and it produces magnetic field. Okay, whenever there is current in the inductor or in the conductor, there will be magnetic field. So magnetic field is produced by the current. Therefore at the site of my SQUID, there will be two magnetic fields. One is applied magnetic field, another one is field produced by this circuit. See, this circuit is also called as a tank circuit. So that explanation goes like this. RF SQUID loop is placed near LC circuit, which is connected to RF AC source. Illi torsidini nanu. The loop is immersed in a magnetic field of flux phi. So this is a magnetic field of flux phi, and that I want to measure, that is to be measured. Now pass an electric current, oscillating current of course, that means switch on the circuit through LC circuit from the RF source. So in this circuit you pass AC current using this power supply. It induces magnetic flux phi RF. I told you, no, whenever you pass the current, it produces another magnetic flux. Therefore, in this region, I have two flux. One is applied flux, another one is induced flux. So the total flux, external flux, will be phi plus phi RF. That is the equation. So total flux is equal to phi plus phi RF. Okay. Now, between this is SQUID and this is RC circuit, so LC circuit. Between these two, there is a sort of connection, indirect connection. This is called mutual inductance. You might have studied this in PUC. There are two types of inductances, self-inductance and mutual inductance. Okay, so in this circuit means in this SQUID, in this portion, I have applied magnetic field. In this portion, I have AC power supply. AC power supply is producing another flux. So therefore, in this region, that is in the SQUID region, I have two flux added together. Therefore, total flux will change. Suppose if there is no change in the flux, there will be no mutual inductance effect. Please follow carefully. This is my SQUID. This is my LC circuit. I already applied magnetic flux. Now I pass current. This current will produce one more flux. Earlier there was phi, now there is phi RF, total flux will change. Any change in the SQUID immediately will change something here. This is what is called mutual inductance. Any variations in the magnetic flux here cause corresponding variation of the voltage here. This is mutual inductance. In PUC you studied coil experiment. So, illi magnetic flux munche ittu, that is phi. Amele by passing the current I produced one more magnetic field, that is phi RF. Therefore, total flux changed. Because of that change in the flux, another EMF is induced, that is mutual inductance. Too many things are there, too many confusing things are there. Please follow carefully. SQUID, RF coil, SQUID with original flux, RF with AC source. When AC source is on, another flux gets into this, total flux change. That total flux change again induces EMF according to mutual inductance. Therefore, V, voltmeter reading, will change. By knowing the voltmeter reading change, you can make out the variations in the total flux. If you know the total variation or variation in the total flux, you can easily calculate the applied magnetic flux. Actually, my intention is to find the applied magnetic flux. Where actually I am applying the magnetic flux? To the SQUID I am applying the magnetic flux. Actually, SQUIDs are used to scan the body. In our body, we have very thin magnetic field. In brain, in heart, we have thin magnetic field. This magnetic field is of the order of 10 power minus 17, minus 18, minus 20 Tesla, like that. Suppose if there is any change in the blood circulation, magnetic field will change. So if you can make out that change in the magnetic flux, easily you can determine the variations in the blood circulation. Thereby you can diagnose the body, you can diagnose the problem. For example, in your heart, some veins are blocked. So you can easily make out by verifying the change in the magnetic field. Or in the brain, some veins are pressed or damaged due to some accident. So you can easily make out where actually the diseased part is. So there you operate and set it right. So how do you do that? With the help of finding the changes in the magnetic field. How do you find the changes in the magnetic field? With the help of SQUID. So that's all. So this explanation here, just I will read it for you. The loop is linked to circuit through mutual inductance. I told you, no, there is mutual inductance. By chance, if the flux in the loop changes, there will be corresponding change in the external. If this is changing, this also will change. Why this is changing? Because of some changes in our body. I told you, no, where there may be some problem in the heart, there may be some problem in the brain, veins are compressed or veins are enlarged due to age factor. So phi will change. Then there will be phi external change. Next sentence, any change in the external flux will induce EMF in LC circuit. So E circuit ಅಲ್ಲಿ EMF induce ಆಗುತ್ತೆ, and correspondingly voltage will change across the LC. V will change. By measuring the change in the V, one can measure external flux and its variation with respect to time. So this is the construction and working of RF SQUID. I hope you got it. This is one of the important application in fact. Well, find the temperature at which there is 1% probability that a state with energy 0.5 electron volt above the Fermi energy is occupied. See here two quantities are given. One is probability of occupation. Probability of occupation is 1%. Where? In a level above the Fermi level. How much above? 0.5 electron volt above the Fermi level. Now let us do this numerical. See, this numerical goes like this. First of all, I write E minus EF is equal to 0.5 electron volt. So that is 0.5 into 1.6 into 10 power minus 19 joule. Okay, next F of E is equal to 1%. That means 0.01. Now I shall find out T question mark. You know the formula for this. The equation for this is F of E. F of E is equal to, I just write F of E is equal to 1 divided by e to the power of E minus EF divided by KT plus 1. For time being, I take E minus EF by KT as X just to reduce the writing part. So F of E is equal to 1 by e to the power of X plus 1. Okay. So now substitute the values. 0.01 is equal to 1 by e to the power of x plus 1, or e to the power of x plus 1 is equal to 1 by 0.01. 1 by 0.01 is 100. So e to the power of x is equal to 99. I want just x. X is nothing but ln of 99. I hope you are following. Now find out ln of 99 using calculator. Ln of 99 is 4.59. So x is equal to 4.59. Now you substitute for x, that is E minus EF divided by KT is equal to 4.59. I want T is equal to E minus EF divided by K into 4.59. So that is 0.5 into 1.6 into 10 power minus 19 divided by Boltzmann constant is 1.38 into 10 power minus 23 into 4.59. Dear students, please simplify this and you will get the answer. Just I will do it for you. 0.5 into 1.6 to the power of minus 19 divided by 1.38 to the power of minus 23 into 4.59 comes out to be 1263 Kelvin. So at such a high temperature, in the energy level above the Fermi level, this is Fermi level, somewhere here, how much above? 0.5 electron above. Only 1% occupancy you can see, still 99% vacancy is there. So this is about this question. Okay, with this I move on to the next module, module number 5. Okay, that is about physics of animation as well as some questions from statistical physics. Okay, dear students, please follow carefully. First question comes here. Elucidate the importance of size, scale, weight and strength in animation. In animation, what are the importances of size, scale and weight, of course strength? What are the importances of these things? Well, I have already explained these things in detail in my video. Please watch my video for more details. Okay, I just give the answers. The ratio of animation size to the actual size of the object is known as scaling or scaling of animation. Dear students, in the description box I have already prepared the notes. Notes means answer for all these questions. The link is available in the description box. You can download, you can practice. Okay, so many students were asking for the PDF of the questions and answers. So question and answer for the entire paper 1 is available in the description box. Please download it. Okay, well, importance of the scaling. Scaling is not only done for altering the size, but also done in the other aspects such as movement, energy, etc. This is essential to distinguish between other parameters such as weight, strength, younger, older, etc. If only size of the cat, I have given the example of cat in my regular video. Cat and kitten, if you reduce the size just like that, you cannot make out whether the kitten is really kitten or it is a miniaturized version of the cat. So you have to scale down properly such a way that cat appears cat only, kitten appears to be kitten only. If you reduce only the size, that reduced kitten, what you call as, is appear to be a reduced cat. ಚಿಕ್ಕ ಬೆಕ್ಕಿನ ಮರಿ ತರ ಕಾಣಲ್ಲ, ರೆಡ್ಯೂಸ್ ಆಗಿರೋ ಬೆಕ್ಕಿನ ತರನೇ ಕಾಣಿಸುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ನೀವು ಜಸ್ಟ್ ಬೈ ರೆಡ್ಯೂಸಿಂಗ್ ದ ಸೈಜ್ ಯು ಕೆನಾಟ್ ಸೇ ಐ ಹ್ಯಾವ್ ಅನಿಮೇಟೆಡ್. ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಸೋ ಮೆನಿ ಫ್ಯಾಕ್ಟರ್ಸ್ ಇನ್ ಟು ಅಕೌಂಟ್. ವೈ? ಬಿಕಾಸ್ ಮಾಸ್ ಆರ್ ವೆಯ್ಟ್ ಆಫ್ ಅವರ್ ಬಾಡಿ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ವಾಲ್ಯೂಮ್ ಅಂಡ್ ಮಸಲ್ ಸ್ಟ್ರೆಂತ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ಏರಿಯಾ. ಸೊ when you animate, all these parameters must be considered. I suggest you to watch my video for more clarity. Here there is nothing to explain. Once again, I am giving only the answer, right? So whatever I explained, it is in the wordings. Here is the importance of strength and then weight. So question is about size, scale, weight and strength. So here is the size scale, here is the weight and strength importance in the animation. Okay, well, with this I go to the next question. Mention the general pattern of Monte Carlo method and hence determine the value of pi. Dear students, I will post one separate video for Monte Carlo method. Please watch that. Anyhow, I will explain now also about the Monte Carlo method. What actually Monte Carlo simulation, when it is used? See, in our day-to-day life, we come across with so many events which are random, where the outcome is not always the same. We cannot predict the outcome result. For example, when you toss the coin, tossing of the coin is an event. When you toss, it will come down either with head or tail. So what is the outcome? Whether tail or head, you cannot say. When you toss, you can say either it is head or it is tail. Okay, suppose if you say head and if it comes with head only, then your prediction is correct. Now I will toss the coin once again. I ask you once again, what will be the next outcome? You cannot say first outcome was the head, now also it is going to be head, or now also it is going to be tail. Andre first time head bandre next time head barutte antande ಹೇಳಕ್ ಆಗೋದಿಲ್ಲ. You cannot say you always get head. Not only 2 trials, 100 trials you do, all 100 times you get head, but you cannot say with confidence 101th will be the head. It can be tail also. So here what head or tail I am calling, it is actually random variables, and the tossing of the coin is a event, and in these events outcome is what head or tail I am telling are unpredictable. In such cases we make use of Monte Carlo method. Monte Carlo method is not only for tossing the coin, it is applicable in so many fields. I give you one more example. Say for example dice. You play dice, either 1 dice or 2 dice or 3 dice. You roll the dice. Okay, let us roll 1 dice, and you know each dice will be having 6 faces with the dots on it, 1 2 3 4 5 6 like that. So when you roll the die, what is the probability of getting 1? Means a face having 1 circle. We cannot say it is going to be now 1 only. It can be 2 or it can be 3 dot, it can be 6 dot, it can be even 1 dot also. Suppose if it comes 1 face, top face having 1 circle, 1 dot. Next time when you throw the dice, you cannot say this time also you are going to get 1 only. It may be 2, it may be 3, it may be 4, it may be 5, it may be even 6 also. So this is what is called unpredictable outcomes. They are called random variables, right? And the probability of getting that particular variable, it depends on so many factors. That is called probability distribution. Now let us come to first example, coin example. I explain all these things in my video, you please watch it. When you toss the coins, both the coins will come with head, or both will come with tail, or one come with head, one come with tail, or one come with tail, another comes with head. Now the probability of finding 2 heads, only 1 time. No heads, only 1 time. 1 head, 2 times. Got it? How it is 2 times, how it is 1 time, how it is no. 2 heads barodu yavaga when both the coins land up with head. 1 head barodu yavaga when one coin is landing with tail, other one head, vice versa. No head barodu yavaga when both will land with tail. So this is what is called random variable, probability distribution, etc., etc. And such type of events, such type of experiments or processes are explained with the help of Monte Carlo method. Monte Carlo method is not only there for dice or coin or playing cards. It is there in business, stock market, physics, artificial intelligence, computer programming. In fact, we have what is called Monte Carlo algorithm, Monte Carlo simulation, etc. So, when the events are random, we can predict the outcome with the help of Monte Carlo method. Okay, and this is one of the beautiful method for finding the outcome in random variation. For example, stock market. Stock market is varying like anything. You cannot say tomorrow what is going to happen, in next 1 hour what is going to happen, whether market is up or down. But stock brokers and financial advisors, market analytics, they use Monte Carlo method to predict what is going to happen. Prediction is not just guessing, it is based on certain theories proposed in this Monte Carlo simulation procedure. Okay, so this is just background. Now how to apply the Monte Carlo method? First of all, see the steps involved. You have to set up the I will explain all these things with one simple example in my video. Please watch the video also after you go through this particular question paper discussion. There I have explained all these things with some example. Since here I don't have time, I am just running through the notes only. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, set up the predictive model identifying both dependent variable and independent variables. Next, specify probability distribution. Next, run the simulations repeatedly. And do this until enough results are gathered. I give you one simple example for this. You want to find the average height of human beings in India. Okay, how to find the average height? Best method, accurate method is find out the height of each and every person in this country, okay, and divide it by total number, you get the answer. But is it practically possible? No, it is impossible. Then what to do? So first you identify the domains, identify the places, selecting some states from south, some from north, east, west, like that. That is what is called as set up the predictive model. Okay, next in that predictive model, identify the people, both male and female, like that. Then measure the heights, not all people. Okay, in Karnataka I select a few people, I measure height from Bangalore, from Mandya, from Hassan, from Bagalkot, like that. I measure the heights. While measuring, I must be unbiased. I should not measure only heights of younger generation, or only older people, or only small school children, or only women, or only men. Not like that. I should go for diversified. So measurement should be based on the distribution. That is what is called as probability distribution. Okay, and then you add. So from Karnataka I give 100 data, from Tamil Nadu 100 data, from Gujarat 100, from Kashmir 100. Like that you collect the data from all the states, right? And then you take the average. And this process you have to repeat not once or twice, you repeat several times. That means run simulations repeatedly for better results. Then once you get enough results, once you gather enough results, you find the average. That is going to be the reliable one. Okay, so this is the procedure adopted in finding the output or random output which is reliable output. This is the Monte Carlo method. Monte Carlo method ಅಲ್ಲಿ ನಾವು ಫಸ್ಟ್ ಏನು ಮಾಡಬೇಕು, ಪ್ರೆಡಿಕ್ಟಿವ್ ಮಾಡೆಲ್ ಅನ್ನು ಚೂಸ್ ಮಾಡಬೇಕು, ಆಮೇಲೆ ಇನ್ಪುಟ್ಸ್ ಅನ್ನು ಮೆಷರ್ ಮಾಡಬೇಕು, ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ಪ್ರಾಬಬಿಲಿಟಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅನ್ಬಯಾಸ್ಡ್ ಮೆಷರ್ಮೆಂಟ್ಸ್ ಅನ್ನು ಮಾಡಬೇಕು, ಅಂಡ್ ದೆನ್ ರಿಪೀಟೆಡ್ಲಿ ವಿ ಹ್ಯಾವ್ ಟು ಡೂ ದಿಸ್. ಆಫ್ಟರ್ವರ್ಡ್ಸ್ ಯು ಡೂ ದ average calculation, so to get the answer. In fact, this Monte Carlo method is very beautiful method to find what is known as pi value. Dear students, you all know pi is 3.14111, something like that. So that pi value can easily determine. You can do this experiment at your home now. So what all you have to do though, you just do one thing, take a sheet of paper and just keep on dropping small pins, what we call as office pin, gund pin anta karitivala. You take that pin and keep on dropping the pins on the sheet of paper. Let the paper will be newspaper size white sheet, and keep on dropping the pins. While dropping, you have to drop it uniformly. Don't drop them only at one point. Okay, keep on dropping them. Or if you don't have office pin, do one thing. Take toothpaste brush, right? Dip it in paint and then tap it like this. Keep on tapping. You will get the sprinkles of the paint. So droplets of the paint on the white sheet. While doing that, now you have to do it carefully. Don't do it at only one place. Otherwise, there will be more dense droplets at a particular place. Instead of that, keep on doing like this. So that there will be uniform distribution of dots on the white sheet. Are you getting? No. Now do one thing. Take a scale. Draw one square box. Each side 2 meter. So on the sheet of paper, say this is a sheet of paper. I sprinkled the droplets, or I dropped the office pins. Now you draw the square of side length 2 meter, and then within that you draw the circle of radius 1 meter. Are you getting? Or if it is too much confusing, draw one square here. By the side of it, draw one circle of radius 1 meter. I repeat, square 2 meter and then circle 1 meter. Okay. Now you count the dots, droplets or office pins in the square. Now count the dots, droplets or office pins in the circle. Inside the circle, I call it as Ni. Inside the square, I call it as Nt. Right. Now you take the area of this, number of dots in this, From this 4 data, you can calculate pi. I tell you once again, ಒಂದು sheet ಅನ್ನು ತಗೊಳ್ಳಿ. ಶೀಟಿನ ಮೇಲೆ ಇಂಕ್ ಅನ್ನು ಡ್ರಾಪ್ ಮಾಡಿ ಅಥವಾ ಆಫೀಸ್ ಪಿನ್ಸ್ ಅನ್ನು ಡ್ರಾಪ್ ಮಾಡಿ. ಆರ್ ಇಫ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಸೋ ಕನ್ವಿನ್ಸಿಂಗ್, ಡೂ ಒನ್ ಥಿಂಗ್, ಟೇಕ್ ಒನ್ ಸ್ಕ್ವೇರ್ ಬಾಕ್ಸ್, ಟೇಕ್ ಒನ್ ಸರ್ಕ್ಯುಲರ್ ಬಾಕ್ಸ್. ಓಕೆ, radius must be 1 meter and 2 meter, and then you keep on dropping marbles uniformly. Then you count marbles in the square box, count marbles in the circular box. From the number itself, you can calculate the pi value. How? I tell you. See, it is like this. Whatever I explained, it is in wordings. Consider a square of side 2 meter enclosing a circle of 1 meter. Square na ಒಳಗಡೆನೆ circle ಇರಬೇಕು ಅಂತ ಹೇಳಿದೆ. Not necessary, it can be even outside also. Center of both circle and square coincide. Suppose if the circle is inside the square, then they have to coincide. Generate a large number of distributed random points, uniformly distributed random points. ಇದನ್ನೇ ನಾನು ಆ ಬ್ರಷ್ ಅನ್ನು ತಗೊಂಡು ಹಿಂಗೆ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ದು, ಅಥವಾ ಪಿನ್ಸ್ ಅನ್ನ ಡ್ರಾಪ್ ಮಾಡಬೇಕು, ಮಾರ್ಬಲ್ಸ್ ಅನ್ನ ಡ್ರಾಪ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ದು. ಓಕೆ, ಸೊ ಬ್ರಷ್ ಅನ್ನ ತಗೊಂಡು ನೀವು ಮಾಡಿದ್ರೆ ಡಾಟ್ಸ್ ತುಂಬಾ ಚಿಕ್ಕದಾಗಿರುತ್ತೆ. ಇಟ್ ಮೇ ನಾಟ್ ಬಿ ಪಾಸಿಬಲ್ ಟು ಕೌಂಟ್. ಆರ್ ಯು ಕ್ಯಾನ್ ಕೇರ್ಫುಲಿ ಪುಟ್ ಡಾಟ್ಸ್ ಆಲ್ಸೋ. ಮನೆ ಮುಂದೆ ರಂಗೋಲಿ ಹಾಕಬೇಕಾದ್ರೆ ಡಾಟ್ಸ್ ಹಾಕ್ತಾರಲ್ಲ, ಆ ಥರ ಯು ಕ್ಯಾನ್ ಈವನ್ ಪುಟ್ ಡಾಟ್ಸ್ ಆಲ್ಸೋ, ಬಟ್ ಯು ಹ್ಯಾವ್ ಟು ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್. ಯು ಹ್ಯಾವ್ ಟು ಡೂ ಇಟ್ ಯೂನಿಫಾರ್ಮ್ಲಿ. ದಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. Or if you drop the pins, no, that also you have to drop very carefully. Pins are slightly dangerous because the tip is very sharp. You have to be very careful. Or instead of that, if you can get small pieces, solid pieces of colorful pieces, plastic pieces or something like that, that also you can do. In total, in that region, there must be uniformly distributed random points. Okay, and then these points can be in any position within the square, that is between 0, 0 and 1, 1. Okay, now keep track on the total number of points. Nt is the number of points inside the square, Ni is the number of points inside the circle. Now using Ni and Nt, we can easily calculate. Here is the diagram. See, these green dots are actually representing the randomly distributed points, and I have a circle, black circle. I have a square, red color. Origin is 0, 0. Now I can show that Ni by Nt is equal to area of the circle by area of the square. Area of the circle is pi r square. Area of the square is 2 square. R is anyway 1 meter. Therefore, it is pi by 2 square. 2 because side length I told you not to take it as 2. Sir, what if I can take this as 1? Suppose if you take the side length as 1, then radius you have to take it as 0.5. Anyway, Ni by Nt is equal to pi by 4 because R is 1, 2 square is 4. So that pi is equal to 4 into Ni by Nt, where Ni is number of dots inside the circle, Nt is the number of dots inside this square including this circle. Okay, by substituting Ni and Nt, we can calculate pi value. Dear students, I tell you, if Ni and Nt are very small, that means if your random variables are less in number, final output will be not fully accurate. It will be having error. We cannot rely upon that. Like if you measure only 10 members height in Karnataka, 10 members height in Tamil Nadu, 10 members height in Punjab, like that, then final output is not reliable. You make more and more calculations. So input must be as many as possible. Say for example, stock market. I want to see what is going to happen tomorrow. For that, I should not just look 1 hour back market scenario, not 1 day back market scenario, at least 1 year back market scenario. So like that, you take large number of samples. So this is random sampling, large number of sampling. With the help of that, you get accurate value. Look at this example. I have 3 examples here. Ni 169, Nt 200. If I substitute 169 and 200, I get pi equals 3.38. You know 3.38 is not accurate. Okay, I will change Ni value. If I increase Ni and Nt, well, pi changes. Nodi 3.38 is a 3.12 bantu. But we know pi is 3.1411, something like that. So therefore Ni I take more. Nodi 169 tagondaga estondu variation ittu. When I take 7067 and Nt if I take 9000, then I get pi 3.14. That means by having large number of experimental data, I get more reliable answer. That is the beauty of Monte Carlo experiment. Okay, so if instead of taking 7000, 9000 dots, you take 10,000, 20,000, 50,000, 100,000, like that, any number you can take. By taking more and more numbers, you can increase the accuracy. This is the procedure, this is the method how we can calculate the pi value. If you are really curious, you can perform this experiment at your home. As I told, just take a sheet of white paper. First you design the square and circle and keep on dropping something. See, if you don't get office pin, if you are not able to drop the color paint on the sheet, very simple example I give you. Take grains, ಬೇಳೆ, ತೊಗರಿ ಬೇಳೆ ಅಥವಾ ಕಡಲೆ ಬೇಳೆ ಮನೆಯಲ್ಲಿ ಇರುತ್ತಲ್ಲ, ಗ್ರಾಮ್ಸ್, ಅದನ್ನೇ ತಗೊಳ್ಳಿ. ಕೀಪ್ ಆನ್ ಡ್ರಾಪಿಂಗ್ ಇಟ್. ಬಟ್ ವೈಲ್ ಡ್ರಾಪಿಂಗ್ ಯು ಹ್ಯಾವ್ ಟು ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್. ಸೊ ಕೇರ್ಫುಲಿ ಯು ಡ್ರಾಪ್ ಅಂಡ್ ದೆನ್ ಕೌಂಟ್ ದ ಗ್ರಾಮ್ಸ್. ಆ ಸರ್ಕಲ್ ಒಳಗಡೆ ಎಷ್ಟು ಬೇಳೆ ಬಿದ್ದಿದೆ, ಸ್ಕ್ವೇರ್ ಒಳಗಡೆ ಎಷ್ಟು ಬೇಳೆ ಬಿದ್ದಿದೆ, ಕೌಂಟ್ ಮಾಡಿ. ಆಮೇಲೆ ಅಪ್ಲೈ ದಿಸ್ ಫಾರ್ಮುಲಾ, pi is equal to 4 into Ni by Nt, you get the exact value of pi or nearest value of pi. This is Monte Carlo method, and by using this method we can calculate pi value. Of course, this method is applicable in physics in various fields. Thermal field anta ide, liquid crystals anta ide, allella kuda Monte Carlo method anna ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay dear students, I will stop this video. It is becoming lengthy. I will come back to you with remaining questions. Thank you very much.